Let's take a look at some eye-opening insights from quantum physicists regarding our reality, facts that have the potential to revolutionize our beliefs about life and self. This information turns our understanding upside down, much like Copernicus did to our perception of the solar system centuries ago. Quantum physicists have found evidence that everything is energy at the most fundamental levels, leading to the idea that reality is merely an illusion. This notion challenges traditional views of reality and has been supported by various scientific discoveries, such as the quantum nature of energy. Quantum mechanics explains how extremely small objects simultaneously have the characteristics of both particles and waves. In the early 20th century, there was an unquestioned assumption that the physical universe was genuinely physical, leading scientists on a quest for the elementary point particle, believed to be the foundation of all life. The idea of spatial extension was a central assumption in understanding the nature of matter. This theory was rooted in the belief that matter must have size and occupy space, leading scientists to search for the elementary point particles, such as electrons or quarks, as the foundation of all life. The objective was to demonstrate that reality was not an illusion. However, as scientists started colliding electrons and other particles in the Large Hadron Collider, a swift realization unfolded. The bedrock of the physical world wasn't physical in essence. Instead, everything manifested as energy. The traditional view of electrons and protons as solid planet-like structures, whizzing around a neutron in an atom, turned out to be completely wrong. Electrons, muons, tauons, quarks, and gluons are not tiny entities with internal structures or physical size. They are essentially illusions, composed entirely of energy. They lack dimensions and behave more like events than tangible things. To complicate matters, electrons exhibit wave-particle duality, existing as both waves and particles depending on the experiment. Pinning down their exact location is challenging because, in the realm of energy, maintaining a fixed position proves elusive. Intriguingly, energetic particles can also be in multiple places simultaneously, a phenomenon known as superposition. This capability, exhibited by electrons and other non-particle particles, aligns with the idea that everything fundamentally exists as energy. As physicists look deeper into these discoveries, the conventional notion of reality seems to slip away. Even Einstein, in his later years, expressed uncertainty about the true nature of electrons, highlighting the enigmatic aspects of these particles. So, electrons are fundamentally energy. The implications of quantum theory, which scientists have grappled with for a century, challenge our common understanding of reality. Yet, for mainstream society, these profound insights into the nature of life often go unnoticed. The Copenhagen interpretation is a collection of views about the meaning of quantum mechanics, which is the theoretical framework that describes the behavior of atomic objects. It suggests a way to think about how the mathematics of quantum theory relates to physical reality. One of the key concepts in the Copenhagen interpretation is the wave-particle duality of matter, which means that particles like electrons can exist in a superposition of states, appearing as both waves and particles depending on the context. Entanglement is another concept in quantum physics that points towards an information-based matrix of energetic reality. Entanglement refers to the phenomenon where two or more quantum systems are correlated in such a way that the state of one system is dependent on the state of the other, even when they are separated by long distances. This non-locality of information is one of the reasons why the Copenhagen interpretation is considered widely accepted, as it provides a framework for understanding the seemingly strange and counterintuitive aspects of quantum mechanics. When two particles become entangled, their properties become correlated in such a way that a change in one particle instantaneously affects the other, regardless of the distance between them. This instantaneous communication seems to violate the theory of special relativity, which prohibits faster-than-light travel for an information-bearing signal. This concept of entanglement challenges our classical understanding of reality and suggests that everything is energetically connected at the subatomic level. This perspective raises profound questions about the nature of reality and the role of human consciousness in shaping our experience of the world. It also highlights the need for a deeper understanding of the fundamental nature of energy and information in the context of quantum mechanics. The Copenhagen interpretation of quantum mechanics, which is principally attributed to Niels Bohr and Werner Heisenberg, provides a framework for understanding phenomena such as entanglement. According to this interpretation, the quantum state should not be taken as a description of a really existing physical state, but rather as providing knowledge of phenomena. The Copenhagen interpretation views quantum mechanics as describing the relation between observations, without necessarily pointing to a really existing physical state. In short, the Copenhagen interpretation posits that reality requires an observer. Imagine yourself as the observer shaping the very fabric of reality with your consciousness. Quantum mechanics raises profound questions about the nature of reality and the impact of human consciousness on our perception of the world. Some physicists challenge the idea of an independent, objective reality in the quantum realm, suggesting that observation may be integral to the existence of physical reality. Werner Heisenberg's interpretation emphasizes that reality doesn't manifest until observed, blurring the lines between the tangible and the ethereal. The Copenhagen interpretation, crafted by Niels Bohr and Heisenberg, offers a framework connecting observations to the essence of physical reality. The interconnectedness, uncertainties, and nonlinearity inherent in quantum realities challenge our intuitive understanding, prompting a re-evaluation of how consciousness and universal energy shape our existence. Everything we can see, touch, and feel is made up of atoms, which are the infinitesimally small constituent parts of matter. According to the current model of the atom, electrons repel each other, and this electrostatic repulsion prevents them from ever coming in direct contact with each other. When we touch something, the electrons around the molecules of our bodies interact with the electrons of the object we are touching, creating an exceedingly complex interaction that our brain interprets as touching something solid. It suggests that the concept of touch is illusory and that our senses are not fooled by this illusion. Rather, our brains interpret the physical world based on the information provided by our senses, which are themselves the result of complex interactions between electrons and the electromagnetic field permeating spacetime. The quantum nature of the universe introduces inherent uncertainty and challenges our intuitive understanding of reality. In summary, the sensation of touch is an illusion because, at the atomic level, nothing ever truly touches anything else. Rather, our brains interpret the physical world based on the information provided by our senses, which are themselves the result of complex interactions between electrons and the electromagnetic field permeating spacetime. The findings challenge traditional notions of objective reality and invite us to consider the profound implications of a reality shaped by the unseen dance of energy and the interplay between consciousness and the universal energy that shapes our world. So, what about what we see? Is it real or just an illusion? Our perception of the world is not a direct reflection of reality. Instead, our brains receive and interpret electrical signals that are generated when light, which is a form of energy, interacts with our eyes. These signals are transformed from light into electrical impulses by the eye, and then sent to the brain's visual processing center, where they are translated into the images we see. In simpler terms, the images we see are actually created within our brains, rather than existing in the external world. This creation process occurs through the conversion of light into electrical signals, which are then interpreted as visual images by the brain. This concept also applies to our perception of color. We don't truly see colors in the external world, but rather the reflected light that our brains interpret as color. While this interpretation of color is a useful way for us to understand our surroundings, it is not a completely accurate representation of the external world. The retina in our eyes transforms the wavelengths of reflected light into electrical signals, which are then processed by the brain to perceive color. It's worth noting that the light we perceive is a type of electromagnetic energy, and only a small portion of this energy is visible to the human eye. So, our consciousness perceives the world by processing the complex energy signals received through our senses. The reality is all energy. Now, based on the idea that reality is kind of like an illusion, what is in it for us in this illusion? It's actually motivating. It's like realizing you're not stuck in some rigid script. You can be the director of your own show. Imagine breaking free from limiting beliefs and really getting creative with your life. So instead of feeling boxed in, you start seeing opportunities. It's a reminder that you have the power to shape your experiences. Challenges become more like plot twists that you can navigate and overcome. This mindset shift is like getting the keys to your own reality. You're actively creating and molding your world. So, let's embrace the idea that reality is this flexible, dynamic thing and use it as motivation to go after what we really want. The possibilities are way more exciting when you see it that way. As we conclude our journey into the quantum mysteries, remember, the quest for understanding is never ending. Subscribe for more explorations into the secrets that lie beyond the veil of reality. Until next time, stay curious.